I'm really cooking my GPU.
The National Vulnerability Database contains a dataset of cybersecurity vulnerabilities with metadata associated to security research work. The primary problem with this dataset is the lack of standards for CVE text description. This makes using the dataset as a source of solid reference information impractical for identifying vulnerabilities in software. The CWE dataset, on the other hand, is a well-known and well-articulated set of weaknesses documented in a public dataset that pertains to weaknesses found in software and hardware. Security researchers commonly use both and other datasets when performing exploitation research. Many data scientists have attempted to map CVEs and other open source data sources to exploit data with varying success in terms of industry use. However, cybersecurity researchers are aware of these datasets' features and limitations, and how to use them intuitively in security research work. This project attempts to enhance the usability and efficiency of the CVE vulnerability dataset by building upon a dataset published in 2021 on Kaggle, which maps CVE data to CWE data. In this experiment, I will attempt to train an NLP model to accurately learn if CVE metadata is relevant to CWE data. If this experiment succeeds, the model could then be used to make a recommendation tag on a new CVE metadata field to signify if it's relevant to a CWE base based on this supervised learning experiment. Essentially, this model experiment attempts to capture the intuitions of a security researcher. This is a large project requiring data engineering, analytics, and several techniques in machine learning. This project incorporates the tools and techniques I've learned over the past year of the graduate level data science studies at Regis University. This project builds upon fundamentals of data engineering by using techniques and tools learned from the data engineering course, as well as advanced techniques and tools learned from the text analytics course. The machine learning portion of this project builds on the tools and techniques learned in the deep learning course. The foundation of this project is the use of a neural net to solve an NLP classification problem. The highlight of this project is the demonstration of transfer learning. The inspiration for the transfer learning focus was built upon an article I researched during one of the discussion prompts. I rely heavily on this article for most of the logic to implement the BERT model. The remainder of the project and its problem use case is my contribution to the field. I use a transformer architecture neural network called BERT. BERT stands for Bidirectional Encoder Representation from Transformers. BERT is a state-of-the-art ML model for NLP tasks. It was developed by Google AI Labs in 2018. I chose BERT because of its ability to solve polysemy problems. In other words, it can differentiate words that have multiple meanings based on the surrounding text. My hypothesis is that it is best suited to perform CVE metadata mapping to potential CWEs. This task is also difficult for humans that have been trained in the cybersecurity field for several years. This classification problem is a categorical classification across multiple labels, which is one of the most challenging NLP tasks when compared to common sentiment analysis, although BERT is good at that too. The project is implemented in 2 Jupyter notebooks. The first Jupyter notebook contains the logic needed to prepare an open source dataset for machine learning in a neural net. The second notebook is used to process the prepared dataset for use in BERT. The next few sections provide greater detail on each area of the project. I consider this project experiment a success and that I was able to implement transfer learning with the BERT NLP model. Although I experienced some difficulties with my personal computer hardware, I learned from the experience, which I consider to be more valuable than theoretical knowledge in the field of AI. The next possible test project would be to determine how effective my model is if tested on a dataset from the NVD database. If it could successfully categorize or tag description text with a CWE recommendation, this would allow for faster classification of new CVEs that target software vulnerabilities from 2021 forward. Another project I'd like to pursue related to this one would build upon this model experience to create a model that could then identify CWE ID categories. This would be a much more ambitious project This is because there are greater than a dozen CWE IDs. However, I am very happy with the results of this experiment since the CVE dataset is quite large, and being able to at least tag CVEs as a possible candidate for CWE relevance is a positive step in terms of efficiency. This model could be used to augment deficient metadata the NVD is known for.